Hello everyone, and welcome back to another video. In this particular video, I will be discussing in the process of the nuclear fusion, how might we increase the potential division at which we consume said energy, which would we store within said battery. Well, you'd have to find a way to essentially minimize the output exchange in order to create from the energy the light that which the fusion point would then hold said light, which the fusion point or the core would be made of iron. In order to divide said battery stored energy, you would essentially have to find a way to minimize and maximize the light output behind it at the same time, such as a laser, which if you were to then utilize a laser focused through an element such as the purest form of carbon, which then creates a diamond, which you can create a focal point from, an even divisionary state, which you enter an even stronger refractionary state. And from this particular refractionary state, you would essentially find that the laser light has divided itself to such a potent form that upon the ignition of the actual fusion, you would have a minimal energy consumption compared to the output of said fusion. And we would find a more reliable method of particularly creating this fusion. Whereas currently in the state we're looking at it, we're simply running the current stored within said battery into the reactor core. Now, in the idea of pointing the laser, you could point a laser extremely far because it's a potent form of light. You can alter space and time with a laser. You can reach extremely long distances with a not very consuming of power in order to create said light. Not much power consumption is necessary for that particular type of light, but it has a maximal greatness of output, which in the focalness of a carbon element at its purest form, a diamond, you have the ability to create a hyperfocal, according to the facets that which you create said diamond, and through this beaming of light, we could arise at a divided energy consumption and an increase in energy output of said light, which in result creates a hypofocal nuclear fusion point upon said iron core. And this iron core would not have to be all that big, because from this iron core, in the consumption that we have to create now, its electromagnetic field to stabilize said iron core. Imagine if the core of the sun is maybe the size of the earth, and you can actually fit 1,000 earths or more within said sun. At the potential exchange of said electromagnetic field to stabilize the overall core central fusion, we'd have to minimize the overall fusion point in order to maximize the amount of energy we could generate in a controllable fusion, resulting in now a nuclear reactor that could actually power the electrical grid within Canada, at least. And in doing so, we have to simply change the rate at which we alter the light exchange or energy dispersing into the core of the fusion behind the nuclear fusion point. Thank you.